In this brief presentation, I'll attempt to answer the following three-part question. Part 1. There are over 60 distinct molecules with the formula C3H7NO. One of these is a tertiary amide. Give its line structure. Part 2. Give the line structure and full IUPAC names of two molecules with the formula C3H7NO that are enantiomers of each of one another. Provide a full explanation of how you obtain the IUPAC names. And finally, Part 3. One of the least stable isomers of C3H7NO is shown below. Discuss the factors that contribute to the instability of this molecule, supporting your answer with appropriate diagrams illustrating all factors mentioned. The answer to part 1 is short and sweet. It is called dimethyl formamide and looks like this. Just to check that it is the right molecule, I can check that the image has the same amount of atoms as the formula: 1 nitrogen, 1 oxygen, 3 carbons, and 7 hydrogens. For part 2, I started by drawing two non-superimposable isomers of the formula C3H7NO. For this, I've drawn the R and S isomers of 3-hydroxyazotidine. To get this name, several things have to be done. First, I looked at the central ring, which is a 4-pointed ring with nitrogen. As the ring contains the nitrogen, it is called a azotidine. Next, I looked at the functional group. For this molecule, there is one OH coming from the ring, which in this case is a hydroxy group. Now I need to decide where on the molecule the hydroxy group is situated. Starting at nitrogen, I went around the ring, giving each carbon a number until I got the hydroxy group. In this case, it is on carbon 3. The last step is to decide which molecule is R and which is S. Starting with the left molecule, I assigned priorities to the various groups and had a look at which way it is going. For the one on the right, is going to the right, so it is the R. Now for the molecule on the left, I did the same thing of assigning the groups priorities and looking at which way they rotated, which is again to the right. However, as the lowest priority group is pointed towards me on this one, I need to rotate the molecule to get the hydrogen pointing away from me, which means the priorities have now been rotated to the left, which means this is the S molecule. For the final part of this question, I need to look at why the molecule isn't stable. This molecule isn't very stable because it's a 3-pointed ring, so there is a lot of ring strain. More precisely, geometrically, the angle on the carbon bit of the ring should be 60 degrees. However, as the carbon is a tetrahedral shape, the angle is actually 109.5 degrees, which is a long way off the original 60. The ring strain this causes is enough to break the ring open. So, to conclude, I've shown an example of a tertiary amide in part 1. I've drawn, named, and explained two non-superimposing isomers of C6H7NO in part 2, and I finished by explaining why a triangular molecule of C3H7NO is unstable.